Hello friends, welcome to my channel Competitive Exams Classes, and today we are going to study the difference between PSLV and GSLV. PSLV and GSLV are the launch vehicles which are used for launching of satellites, and they are developed by Indian Space Research Organization, that is better known as ISRO. The PSLV is mainly designed to deliver the Earth observation or remote sensing works, which is used for lifting the satellites up to mass of 1750 kg, 1750 from, and it starts from around 1000 kgs to the sun synchronous circular polar orbits. Sun synchronous polar orbits are the orbits which are basically at around angle of 98 degrees, and the satellites orbit from pole to pole, from the north pole to the south pole, or we can better explain it as the magnetic poles of the earth. But we do not use the word magnetic pole because the magnetic, we as we know that it shifts, so we use the word pole to pole. And an orbit is called a sun synchronous orbit when the angle between the line joining the center of the earth and the satellite and the sun is constant through the orbit. That is basically they are in the same plane. Now, since these orbits are sun-synchronous in nature, and we also refer them to as lower Earth orbits (LEO), which enables the onboard camera to take the images of the Earth under the same sun illumination conditions during each of the repeated visits. That is, the satellite is at the same point of time, at a particular point of time, it is at the same place. That is, for example, if today at 2 p.m. it is at a place named X, so tomorrow also at the same time it will be at the same place. So because of that, we can basically get exact accurate information about a particular place and also the changes. This is used for remote sensing purposes. We can get the information about environment, greenhouse gases, the pollution, the wildlife, or the wildfires which have been taken, which have been, if any wildfire has occurred. Also the changes on the earth due to earthquakes. The hazard mapping is done by this. The plate tectonics is understood by this, and the NDMA issues guidelines via using these kind of satellites. And also the PSLV is used for launching satellites to the GTO, that is geosynchronous transfer orbit, but that which is around 36,000 kilometers from the Earth. But this or this satellite, when it is sent there, the mass carrying capacity is reduced to around 1400, which in the LEO is from around 1000 to 1750, 1750 kg. These two images are of sun synchronous orbit and a geostationary orbit. A sun synchronous orbit, as I said, is from a pole to pole, wherein the satellite moves from one pole to the other, and at a particular mean solar time, it is at the same place throughout its working duration. And in the geostationary orbit, the satellite is at around a distance of around 36 to 38,000 kilometers, and it takes around 24 hours to rotate or revolve, and the direction is usually west to east, and the speed of the satellite is equal to the speed of the rotation of the earth. And also the circular, it has a circular orbit. The only difference between geosynchronous and geostationary orbit is that geosynchronous orbits can have any inclination, but the geostationary orbits have they lie in the same plane as of the equator, unlike the geosynchronous orbit. So this is the image of a PSLV of the ISRO. There are two maroon parts and two white parts leaving the upper part. So the maroon parts are basically used for storage of the liquid fuels, and the white parts are used for the storage of solid fuels. So this is the image which we can see is the image of a XL configuration, which is used for heavier satellite launches. There are basically three versions, which is a core alone, that is, it does not have any strap on. This small missile-like structures at the bottom, they are known as strap-ons. They are basically used for the extension of the thrust, because by which the satellite can carry a more amount of weight to the atmosphere, to the higher atmosphere. And as I said, there are four stages in the PSLV's journey from liftoff to placing satellites into orbit. In the first stage, which is known as PS1, the PSLV uses S139 solid rocket motor, which is augmented by six solid strap-on boosters. It provides the launch, the high thrust that is required for the liftoff. That is at the bottom, the white part at the bottom. It is used for, and it has around 138 tons. The capacity is around S139, means 138 tons of so the fuel it is stored in it, and the fuel is basically HTPB, that is hydroxyl terminated polybutadiene based propellant, and it is used for the launch of the vehicle. And the six strap-on boosters, it helps in that. In the second stage, the launch vehicle uses earth storable liquid rocket engine, which is known as Vikas engine, which was developed by LPSC in early 90s, Liquid Propulsion Systems Center, LPSC. The third stage, PS3, involves a solid rocket motor that provides the upper stage high thrust after the atmospheric phase of the launch. This is the penultimate stage of the PSLV, using a solid rocket for propulsion. And the final stage is the uppermost stage of the PSLV and comprises of two earth storable liquid engines. This stage is responsible for the correct injection of the PSLV payloads into the desired orbits, either it be the geosynchronous orbit or the lower Earth orbit. The three versions which are developed by the ISRO of PSLV have basically the first, that is core alone, wherein it does not have any strap-on motors which are used for. It is basically used for very low weighted satellites. And then there is a standard configuration with strap-on motors, which has six motors to provide thrust, and the XL configuration, which also has six motors. The only difference here is the capacity of fuel carry. That is, for the standard configuration, the fuel which is used is a bit less as compared to the XL configuration. This is the image of the GSLV, and the GSLV is the largest load carrying satellite launch vehicle which is developed by ISRO, and it is used in India for launching the uh, communication satellites to the geosynchronous orbits or the geostationary orbits. And it has basically three stages. The three stages comprises of solid stage, liquid stage, and the cryogenic stage. In the image, you can clearly see the three stages: S200 stage, L110 stage, and C25 stage. The 200, 110, and 25. This figure stand for the amount of fuel which is stored in it. The solid fuel is around 200 tons. The liquid is around 110, and the cryogenic is around 25. GSLV basically is a satellite which works in three stages, unlike the PSLV, which is a four-staged working rocket, and it has three versions. The three versions are GSLV Mk1 Mark 1, GSLV Mark 2, and GSLV Mark 3. The GSLV Mark 1 is basically has a capacity of around 2 tons to the GTO, the geostationary orbit. The GSLV Mk2 has a bit added capacity of around 2.5 to 3 tons to the GTO, and it has an additional four strap-ons. The image which we have seen in the previous slide, it is of the GSLV Mk3, which has two solid boosters, and the image of the PSLV, which had six strap-ons. The GSLV second version is more or same. It looks alike. It is look-alike of that version, but the only difference is that it had six strap-ons. Here we have only four strap-ons, and its capacity is around 3 tons to the GTO. The 3 GTO is around 36,000 kilometers altitude from the Earth, and the PSLV carries it to the low Earth orbits, to the lower Earth orbits, and its capacity to the GTO is not more than 1,000 kgs. the GSLV Mk3, which is the most suitable or the highest load carrying capacity launched vehicle, which is developed by ISRO, and it has a capacity of around 5 tons to the GTO and of around 10 tons to the lower Earth orbit. And this will be the satellite, the GSLV Mk3 will be the satellite which was used either for Chandrayaan 2, and also it will be used for the most awaited Gaganyaan project of the ISRO. This GSLV is designed mainly to deliver the communication satellites, wherein we basically the communication which we carry out throughout the earth, the communication, the meteorology, the tele-education or telemedicine. Also, it is used for disaster management, where we can, study the risk and vulnerability assessment of a particular cause which is caused by a particular disaster, and its mitigation strategies and the preparedness also can be worked upon by using the images which are provided by this satellite. The GTO is further raised to its final destination, that is the geosynchronous or the Earth orbit of around 36,000 kilometers by firing it in built-on board engines. That is, it is maneuvered from the Earth and it is basically put up into the required orbit. And due to their geosynchronous nature, these satellites in these orbits remain to appear permanently fixed in the same position in the sky. That is, suppose we see it from a point say X today, we will see it at any point of time. We will see the satellite at the same place at any point of time. So there is no need of any ground antenna which tracks about the position of the particular satellite, because it is seen to be fixed at a particular place, because the time it takes for rotation and revolution is same as the time which is taken by the earth for its rotation. And the GSLV program was started in around 2001, unlike the PSLV which was developed around 8-10 years earlier of the GSLV. And this and these versions have a cryogenic upper stage. A cryogenic engine is basically a engine which stores fuel, liquid hydrogen or oxidizer. That is a liquid oxygen at very low temperatures. Hydrogen liquefies at around 20 kelvins and oxygen at around 90 kelvins. So this generates high energy thrust by burning hydrogen. Now oxidizer is used because in the outer space there is lack of oxygen, and the various capacities of this engine of this launch vehicle, as I stated before, are around 2500 kgs, around 3000 kgs, and around 5000 kgs to the GTO, which increase to the lower Earth orbit to around 3 to 5 tons for Mk1 and Mk2, and it is around 10 tons for Mk3. Thank you for watching the video till the end, and please don't forget to subscribe the channel.